So the question was why electron is having negative charge. Actually, value itself is a charge. Now see, there are a lot of difference among many terminology. One is called as a mass, second is called as a charge. Right? So we'll discuss this also, what is difference between mass and charge. But before that, we need to understand what we mean by the negative value. Say you might have studied in a mathematics that there is a zero and the line or number above zero is called as a positive and below zero is called as a negative, right? But if somebody will ask you that can you explain this thing with example, real-time example that which is having negative value and this is called as a positive value, then how will you explain them? If somebody will ask you that give me the example that this represents a positive value and this represents a negative value. Is there any example? I'll give you a very simple example. I'll correlate that example with our own concept of current, because ultimately we are going to understand two terminology, voltage and current, right? So I'll correlate this with this two terminologies also, right? So see, as we know that this is a nucleus. Now around nucleus there is a proton and electron which rotates, right? So we are not going into that level, macro level, which is called as a, so there are positive charges and there are negative charges, right? So I have circled that negative charges and they may rotate around nucleus. Similarly positive also. That is in a macro level, and it is very difficult to see this rotation by using even microscope also. Now, in order to understand this concept, so see, this zero means what?
No
what do you
value.
mean by zero?
No value.
Zero means nothing. Zero means nothing, right? So if I'll say that, let us say we are having a, for example, a dish and we are having 2 apples in the dish, right? Then we can say that there are 2 apples in the dish, right? But if I'll say dish is empty, there is no apple, right? Then I'll say that there is a zero apple. When can I say that there is a minus apple? Can I say?
Yes.
And from where this concept have come? Can you give me the example that there is a minus apple? Then?
No.
So in order to understand this concept, we have to take another example. See, this example is not sufficient to explain you the concept of negative, right? So in order to explain you the negative, I'll give you another example. Now let us assume that there is a ring. Now on that ring, now this is at this position. This is the ring is at this position, which we call it as a reference position. Which we call it as a reference position. We don't know whatever is the position, I mean height, right? It may be at the ground level, it may not be at the ground level, it may be at certain position, it may be on a one location, right? We imagine that it is in the space and it is on one position, right? Now let us say if I'll connect let's say many balloons to it, n number of balloons. Now what will happen? Naturally, this will be lifted. These are all, let us assume that hydrogen balloons, sorry, not bubbles, balloons, right? Now due to this, it will be lifted. Now that means it has moved to the one direction, and that direction I am representing as a positive direction, right? Now let's say I have connected 1, 2, 3, 4 and 5 balloons. So it has moved from this position to, let's say, this position. This whole dish has moved at this position. So similarly, it is lifted at this position. So it has moved to the positive direction. Now what I am doing? I am removing balloons, right? Now I am removing the balloon. So what will happen? Naturally, from this position, it will come slightly below. It will come slightly below, right? Similarly, if I remove one by one, then it will again come to the reference position. It will again come to the reference position, right? Okay. But in that case, we can say that it has travelled a negative distance. In that case, we can say that it has travelled negative distance. But still, it is not. It's still little bit hazy. I mean, it's not little. It's still not clear that whether it is negative or not, because we have moved from one position and we have lifted, and then we have come back to the original position. So it is something like you are on the 0, you moved on the positive side, and again you come back to the 0. So what about negative? Are you getting my point or not? Right? Now I'll do some extra thing. Now instead of bubble, let's say I'll connect some stones over here. Right? Now what will happen? Instead of moving up, it will move in this position, down, right? This dish will come at this position. Are you getting my point or not? Similarly, if I connect another stone, it will go into the next level, right? Now you can say that from this reference level, the disk is moving in a one direction as well as in the opposite direction, right? So that we can say that, okay, now I can say that this reference is my 0. This reference is my 0, means there is no bubble. I mean balloon, sorry, I am again and again recalling that bubbles, right? So means nothing is there on the disk. So nothing means 0. When I connect balloons which is having let's say hydrogen within that, then it lifts the disk and it will go into the positive direction. Then I may keep the bubble as it is, and I may put the stone. I may keep the bubble. It's not like I can remove. Depending upon the weight of the stone, the disk will come into the negative in a reverse opposite direction, and it will go below the reference line. The moment it will cross the reference line, now what is the reference line? A line where we have assumed that there was nothing. 0 is what? Is a point where we have assumed that there was nothing. Right? So that point we call it as a 0. Above that point we call all values are positive. Means magnitude is positive. Below that we call it as a negative. Clear? It's very simple, but it's, I don't know, if you need to explain to the school kids I think nobody will explain with this manner so that they can understand, right? So this is what the concept of negative value. Now, what is the relation of this concept with our this voltage and current, right? So in this case, now question is, see, both voltage and current are correlated, right? Correlated in the sense they are having linear relationship. Now you know that Ohm's law and everything, so I am not going into the detail of that. But means without voltage there cannot be current. Without voltage there cannot be current. Now again we'll come back to the original figure wherein we have a nucleus. Now you can consider this nucleus is same as a ring. You can consider this nucleus same as a ring. Now in this nucleus, if now what is mass and what is charge? Now that is also very important terminology which you need to understand, right? So what do you mean by mass? What do you mean by mass? Weight is different.
दौड़ क्या है?
Weight is different. What is mass? What is mass? Mass of an object.
Anything which has a volume inside it.
You are introducing another terminology, volume. I'm asking mass. So mass is a one parameter. Once you say volume, it will become another parameter. See, if you are talking about voltage, voltage is one parameter. If you are talking about current, you are making two parameters, two quantity rather than using the word parameter. See, these two are very important word, parameter and variables. Variable and parameters are very important word which many people do not differentiate these two terminology, right? So mass of an object is nothing but a matter within that, matter matter within that, right? So whatever is the particles, it is made up from particles. So let us say we have a block, right? Now if this is, let's say, a block of wood, then there will be a minute particle of woods, right? So it is a amalgamation of all the particles within this block. Now when you apply a force to this block, all the particle will have a equal displacement. All the particle will have a equal displacement. It will not happen that this particle will have a delta x and this particle will have a delta x twice delta x. It will not have like that. All will undergo equal displacement, right? Okay, so that is physics. But what is mass? So mass is nothing but it is a matter within a object. It is a matter or through which it is made up. In a simple language, in a nutshell, through which it is made up. Now what is charge? So charge is a physical property. Charge is a physical property of matter. Charge is a physical property of a matter, right? Now once I am using the word physical property, physical means it's a physics. Physical means it's a physics. So see, there is a 2-3 point which differentiate between mass and charge, right? So I don't know whether you are aware about it or not. If you are aware, then I'll skip it. If you want, then I can differentiate this. Are you aware about a difference between mass and charge? Do you want me to repeat? Do you want to understand?
Yes.
Yes.
Okay. So, have you understood the difference between mass? Mass is a matter, or it's a, you can say that it's a minute particle within the object and through which it has made up. Right? See, another thing is, see, in order to make an analysis, the general practice is we dissect. General practice is we dissect. But up to what level you will dissect? Right? If you want to analyze this block, you break it. Right? So you have this much of block. Again you break it, break it, break it. Up to what level you will break? Right? Because there is no limit. Even this small particle is also having a lot of chemistry. The small particle is also having a lot of even particle which is having size in terms of nanometer or maybe less than that. It's having its own chemistry, right? So that theory works up to certain extent. That theory works up to certain extent. If you keep on breaking the object, and if you want to analyze what is happening within that theory will not work forever. I'm not saying it's a wrong theory. Please try to understand. You can understand up to certain extent, but not as a whole. Are you getting my point or not? In order to understand everything in detail, this theory will not help you. Right? Okay. Even the things which we are going to understand, in which there is a nucleus. Now there are some positive value and there are some negative charge. Or instead of using a charge, I'll give another name: electron and protons. Electrons and protons. So these are also particles. Actually, these are also particles, right? So these are also moving around this nucleus. Electrons and protons are moving around this nucleus. So we say that, and there is another particle which we call as a neutron. Three particles: electron, proton, and neutron. Right? So now what is the difference? Electron is having negative charge. Positive.
No charge.
No means zero. Whenever I'll use no, nothing means zero, no charge. Right? So we don't know. There may be some neutron also. Right? Now in order to understand this whole thing, if you dissect it, it is difficult to dissect the molecule. It is difficult to dissect the molecule, because if you break this, dissect means if you break this, again there may be something. We don't know what is within that. Again, if you dissect, what is there, we don't know. You getting my point or not?
Yes.
So it is very complicated thing, right? So anyway, you understand up to this extent that there is electron, proton and neutron. Electron is having negative charge, proton is having positive charge, and neutron is having
No
charge. Okay. Now we want to quickly differentiate between mass and charge. So I'll use about Q in order to, as you are already familiar. So as I've told you, mass is what?
Matter.
A matter within an object. Now what is charge? It's a physical property of the matter. Now what is physical property? Physical property means whether it is having a positive, or whether it is having negative, or whether it is having a zero. This charge is a physical property which we are representing. It is some property which we are representing. Now what is this property? That I am not explaining you. It's a force. Let me clear you. It's a
Force.
force. Force is a physical property, right? So when I'll say that physical property, then you'll ask me the question, what is physical property? Right? So physical property means force is a physical property wherein you may have a negative, you may have a positive, you may have a zero. Zero means that no force, right? Now, mass is associated with the force which is called as a gravitational force. Which is called as a gravitational force. Right? So whenever two objects are there, there is always a gravitational force between two objects. There is always gravitational force between two objects. Right? Now here, in this case, there are two types of force which we call as a electromagnetic force. Sorry, electromagnetic force. So it's a two words. Electromagnetic is a two words. It's not a single word. Try to understand. Electric plus
Magnetic.
magnetic. Right? It's a combination of two words which called as a electromagnetic. So two types of force are possible. I am not saying always two types. It depends upon the condition in which electron is residing, state. Right? So depending upon the status of the electron, whether it's an electric force or whether it's a magnetic force or whether it's a electromagnetic force. Are you getting my point or not? Yes. So combination is there. Now mass, charge. Now is there any other difference? Okay. Now third word which you have added is a weight. So what is the difference between weight and mass? What is weight and mass? It's very simple. You should know this thing.
Weight will be amount of mass now amount of like it will be an amount.
This is what amount of matter in an object is a mass. It may be any matter. See, blood and flesh is a matter. Right? Bone is a matter. Right? So, what is weight then? So, how do you write the specifications of the machine? In terms of mass or in terms of weight?
Weight.
Weight.
How do you measure your weight? In terms of mass or in terms of weight?
Weight.
Have you ever thought that why we call it as a weight, why not mass of body? It should be mass of body, na? Why do you call my weight is 60 kg, 70 kg? You should tell my mass is 60 kg, my mass is 70 kg. See, weight is equal to mass into G, gravitational force. And that's why you might have heard this thing that weight is different at different planets. If we go to on the moon and if we measure our weight, it will be different. You might have heard. You have not checked. Have you checked? No, nobody has checked from this group. We have heard it, so we have to believe sometimes. Right? Whatever I am telling you, you have to believe. So, weight is equal to mass into gravitational force. So, when you multiply G with the mass, then it becomes weight. On a Earth, it is a
9.81
9.81 meter per second
square.
per second. Something
Second square.
second square,
Second
right?
square.
Okay. Now another property is it is having a mass is having a inertia. It is having a inertia. Mass is having inertia. What do you mean by the word inertia? What do you mean by the word inertia? What do you mean by inertia? So in a nutshell, I'll explain you. If I'll ask you to stand up, how much time will you take to stand up? It depends. It depends on my mood. Right? Huh?
1-2 seconds.
So why 1-2 seconds? Let us say 1 second. Why 1 second? Why not the moment I said stand up? Why you have taken 1 second?
Movement was different.
Because of the inertia of the body, it will take some time. Because of the inertia of the body, right? It will take some time. It will not all object is having an inertia. They'll take some time to respond. All the object will take some time to respond. It may be in a microsecond or it may be in a minute. It depends on the characteristics of the object, which is called as a inertia. Are you getting my point or not? So inertia is associated with the mass. Inertia is there in the mass. Okay, now let us come back to the original discussion. Now electron negative, proton positive,
No charge.
zero, no charge. Now what will happen? So as I have told you, there are two possibilities. Depending upon that, it will have a either electric force or it will have a either magnetic force or it will have a electromagnetic force. It depends, right? Now if electron is rotating in its own orbit, okay, now let me ask you a question. Are you stationary right now? Are you stationary right now or you are rotating right now?
Stationary.
Yes.
Agree? Stationary? मानसिकन શું લાગે તમને?
हाँ स्टेशन
કોઈ બોલતા નથી. You are not saying anything, so. Stationary?
यस सर
I'll prove that you are not stationary.
because we are on the earth and earth is continuously moving.
Right? So we are continuously moving, and not only moving, we are moving with the two different rotations. We are not stationary. You imagine that earth is a big plane, we are in the plane and it is continuously moving. So are we stationary right now? We are not stationary. In fact, we are rotating with the two speeds. In fact, we are rotating with the
Two speeds.
one is
Rotation.
Rotation, revolution.
Second is
Revolution, rotation.
revolution and
Rotation.
we are rotating along its own axis. This is called as along its own axis. And if we rotate on some specific path, so we are rotating surrounding sun, around sun. We are rotating around sun, and also we are rotating with its own axis of the earth. So there are two types of rotations, and another thing is we are inclined also. Surprising thing is we are inclined. So we are inclined, rotating, and then revolving. Not only that, this is only one. This is in one galaxy. This is in one galaxy, right? So this phenomenon is occurring in one galaxy. Now you can imagine there are n number of galaxies, and galaxies themselves are rotating. You can imagine the complexity of the universe. You can imagine the complexities of the universe, right? So we are rotating along its own axis, revolving around sun. Whole thing that is revolving within a galaxy. On which galaxy we are?
Milky.
On which galaxy? What difference does it make? Right? It's right. What difference does it make? Why should we worry about all this thing? Right? Why should we worry about all this thing? So we are on the Milky Way. See, this is what I am telling you the story. I have not experienced all this thing. I have not gone to the Milky Way. I have not gone to the end of the planet and tried to see. This is what I am trying to tell you the story. Whether if you want to believe it, you believe me. If you don't want to believe me, you can listen and you can remove.
Milky Way.
And that's why I use the word story.
Story.
So story is an imaginary thing, right? So again, come back to this point. Electron. Electron is
Moving in its own hand.
moving around this nucleus, right? So we call it as a. It's not moving in a one particular direction. It's not moving in a one particular direction. It's moving around its nucleus, right? So it's moving, but it's a moving, right? But if we consider two electrons, having one electron having charge Q1 and another electron having charge Q2, can we have a different charge for different electrons? Can we have a different charge for a different electron?
No.
Okay, then make Q1 is equal to Q2, right? Then let us make Q1 is equal to Q2.
Q2.
Right? Then the force between these two. There may be a force between these two because, as I have told you, because this electron is also having a mass. See, charge does not mean that it is not having a mass. This is very important concept. You should understand this thing. Electron is also having a mass, right? Because it is a particle. Its object. It is having a mass, but what is different? Its property is different because its property is to give force, negative force. Property is to give negative force, right? Now what is negative force? It attracts. Negative force means it attracts. Positive force means it repels. Positive force means it opposes. Negative means it attracts, right? So there is a force between these two. Now both are
Same charge.
No. So what will the effect? Both are electrons. So what will happen?
Repulsive.
Do this. Sir.
Huh?
Repulsive.
Both will be in a repulsive
Positive.
opposite force. So there is no attraction. There is no
Attraction.
And you know that there is always attraction between
Positive and negative.
positive and
Negative.
negative. There is always attraction between positive and negative. So this will not, definitely there are forces, but the forces are in opposition, clashing. They are trying to meet each other. This force try to attract each other. Clear? So this force is from, who will give this force? Who will give this force?
Protons.
Who will give this force?
Electron.
Electron. Right? So you have to make a system in order to flow the electron. There must be a protons who attracts the electrons, or in a reverse way, there must be electron which attracts the
Protons.
photons, right? But see, this is a little bit difficult to convince yourself if you go in a negative way. That negative attracts positive is little bit difficult to understand from our logical thinking, right? This also nobody has seen. Only thing is we can experience, right? So if you really want to understand what is universe, you have to experience. You cannot see, right? You have to close your eye and you have to feel. That we cannot do. We don't have that much of power, right? The moment we'll have, we'll close all these things, right? So in order to understand this thing, we cannot dissect everything and we can see. There is a limitation for that. But if you really want to experience what is happening even in a minute particle, you have to experience and then tell. I hope that it's a big statement I'm giving it to you. I don't know whether you are able to digest it or not. Right? So in order to understand something, sometimes you have to experience. Not always you can say that give me the proof that how much is the fat and how much is the what? SNF. Somebody may close their eyes and say that check this milk, it is having 6.2 fat and 7 SNF or whatever it is, right? So for them they do not require any of the instruments, so they are above the humans. See, and there are people, right? We have not met with such kind of people, that's why we do not believe them. But anyway, this is all spiritual thing, so I'm again coming back. Okay, so there is a force between these two, and this can be measured, and there is a specific formula, F is equal to Q1 Q2 by something. I don't remember that formula because it's a mathematics, so forget about that formula. But there is a formula for resultant force. There is a formula for resultant force between two electrons. Right? Now, when electron is stationary, there is a force which called as a electric force. Electric force. We call it as a electric force. Now, the moment electron is rotating or moving, the moment it is moving, we call that it introduces another force which is called as a magnetic force, right? So see, I don't know whether you have what is right hand thumb rule. What is right hand thumb rule?
કંઈક આવતું હશે ને
Those who have a right hand and those who have a thumb, they can say that we know the rule. Right? What is right hand thumb rule?
This is force, this is current, and this is the direction.
What is the direction of? See, this is not force.
So this is current, this is force. Okay.
You have to point your thumb in the direction of flow of. Finger indicates direction
field.
of generated magnetic field. So magnetic field will be generated like this. See, this is not force. You are saying this is force.
Current.
There is no force. Then magnetic field will be like this. So if this is a rod or a straight conductor, then depending upon this, you will be having magnetic field. And up to what distance magnetic field will be there? It is inversely proportional to R square. Even I don't want to remember, I don't want you to remember. You just understand the relation. That is more important. You can refer the formula in any of the book or on Google, right? But important is you should know the relation. It is inversely proportional to the distance. R square is a distance, right? So more the distance, it will reduce. Magnetic flux will be reduced. If you are nearer to that, more magnetic field. I am talking about electromagnetic force. So when there is a current is flowing through the conductor, right? If current is flowing through the conductor, then it is having two force. One is called as a electric force and another is called as a magnetic force. Both the forces are exist, which is called as electromagnetic force. Both the forces are exist, which is called as a
Electromagnetic force.
Right? So both the forces are exist and which is called as a electromagnetic
Force.
right? So now let us talk about this thing. A simple battery. Now what is there within a battery? What is there within a battery? Storage of charge is there, right? Now that means what? There are some positive charge, there are some negative charge. So now in order to make this, you have to make a chemical structure in such a way that it will store the energy, right? Now, do we have a current now? The question: do we have a current in this?
Open circuit.
See, if you measure up to this point, then there is a flow of electron up to this point. There is a flow of electron at the tip of this point, right? But it cannot complete the path. It cannot complete the path. So you will not experience anything. If you will touch only this portion, then you will not experience anything. Unless until you touch both the portions, top and bottom. Even if you touch this portion, you will not feel anything. Right? So in order to pass the current, you should form a closed path. You should form a closed path. Then and then this current will form a path. What is current? Current is a flow of electron. We are saying that it's a flow of electron. Electron stationary is not a current. It's a flow of electron. So if there is a flow, then and then we call it as a current. Otherwise it's not current. Right? If electron is resting, we cannot say it's a current. But in order to have a current, electron has to flow. Now how it will flow? the question is how it will flow. How it will come at this point. Forget about this point. How it will come up to this point.
Force must be there.
You have to give force. You have to give force to the electron, then and then it will move. Depending upon the force applied, electron will move. Now electron has moved. Now what is the direction of flow of current? What is the direction of flow of current?
Positive to negative.
Do yeah.
Never use this statement.
Low resistance pipe.
I am asking what is the direction of flow of current. There is nothing like positive to negative or negative to positive. No doubt it is coincidentally it is matching. It's not a right word to use. The direction of the flow is in opposite direction of flow of electron. This is the right definition. So if electron moves from negative to positive, now understand, electron moves from negative to positive, then current flows from
Positive to negative.
positive to negative. So what is the direction of flow of, what is the direction of current?
It will be opposite to that of the direction of the electrons.
Direction of flow of current is in opposite with the direction of flow of
Electron.
electron moves like this, current will move like
This.
this. Simple.
Reverse direction.
Clear?
Hmm.
Direction of flow of current is in opposite with the direction of flow of electrons. Now you can imagine, this is a positive. It will attract what?
Negative.
So electron will be moved from here to
Here.
here, and hence current will flow from
Positive.
Positive to negative.
positive to negative. So
Negative.
do not try to this is called as a cramp. Try to understand. Clear? Okay. So who will give a force to move this electron?
Voltage.
Voltage will give force to move the electrons. Clear?